Hello and welcome to this Alva instructional video. My name is Lars-Endre Mæland and I'm a principal mechanical engineer here at Alva. In this video I will show you how a thick bond line concept can be used to integrate the Alva SlimTorq motor into your application. If you have questions about the topics in this video or want more information about our products, please check out our product catalog or visit us at alvaindustries.com. In a thick bond line solution, the gap between stator and stator housing, or rotor and shaft, is relatively large, on the order of tens of millimeters. This allows for a wider selection of adhesives to be used, for example adhesives with higher thermal conductivity. Radial alignment can be ensured in one of two ways, either by keeping an alignment fit on part of the interfacing surfaces, or by using a jig to hold the part in the correct place while the adhesive cures. The second option can be a good choice if for some reason it's unfeasible to achieve good alignment by assembly tolerances alone. For example, if the stator housing is made by a less accurate production method. By having a tool or jig that locates the part, some of the misalignment can be corrected for in the glue line. This can be done for both stator and rotor. However, we generally do recommend that the rotor be aligned by machined surfaces on the shaft, as this is generally more repeatable and accurate. When assembling the parts, some adhesive squeeze out is to be expected. This should be accounted for in the design so that it's possible to clean off any excess and that it doesn't get anywhere where it might cause trouble, such as into a bearing. Something to note about the thermal performance of the bonded interface is that the thermal resistance is given by both the thermal conductivity of the adhesive as well as the thickness of the bond line. This means that a really thin bond line with normal adhesive might have similar thermal resistance to a thick bond line with highly conductive adhesive. In any case, the worst situation for thermal performance is if there is air-filled voids in the bond gap. So good filling is important no matter the choice of adhesive. Now I will show you how we can use a thick bond line concept to attach the stator. We'll use our 8524 motor in the dummy assembly as an example. In this case, the stator is fitting loosely in the stator housing, so we will use an alignment tool to align the stator to the bearing board. The rotor has already been assembled onto the shaft by use of a thin bond line method. First we clean the stator OD and housing ID with isopropyl alcohol and a lint-free cloth. We then rough the surface of the housing using 80 grit sandpaper. Then once again clean with isopropyl alcohol and a lint-free cloth and let the surfaces dry thoroughly. We then apply adhesive evenly to the inside of the stator housing, making sure to cover all the surface. The housing is then ready to be placed on the alignment tool. Then we apply the adhesive in a nice even layer to the outside of the stator, again making sure to cover all the surface. Now we are ready to assemble the stator into the housing. Any squeeze out is cleaned off as needed. After one final cleanup, the adhesive is allowed to cure. Now the adhesive have cured and we have disassembled it from the aligning jig. So now we're ready to assemble it together with the rotor. And there we have a framed motor using the thick bond line concept. I hope that you found this video both informative and inspirational. On our website alvaindustries.com you will find our product selector, which is a great tool for finding the correct SlimTorq motor for your application. If you have any questions about the topics in this video, please do not hesitate to reach out to us. So, in which application will you use Alva SlimTorq motors? Let us know in the comment section below.